Welcome to the office. We want to take a look at section 5 today. So subgroups is what we are interested in here. For subgroups, we're actually going to start off with a conversation on notation and terminology. So I'm saying it's notes on notation and terminology here. In our last video, or let's see here, maybe a couple of videos ago now in section 4, I kept using the word multiplication instead of star to describe the binary operation. And the reality is that's pretty common. It's common to simply use multiplication and addition as the notations for the binary operation. So it's often multiplication and addition are used to denote the operation, the binary operation, even if we're defining it a little bit differently. All right. So if that's the case, then 0, let's see here, let's put them in the same order as that. So 1 and 0 are used to denote the identities when using multiplication and addition as the operations. So trying to be respective here. When we're using multiplication, we use 1 as the multiplicative identity. When we use addition, we use 0 as the additive identity. Even if under the circumstances, right, even if under the specific group we're working in might not actually contain 1 or 0. We simply use those to denote the identity when the symbol happens to be that of multiplication or addition. With that same idea, we get the notation for inverses. So when we have inverses under multiplication, denote the inverse of a as a to the negative first power. Right, that's what we do for multiplication and multiplicative inverses. 3 times 3 inverse is equal to 1. Hey, right, that's familiar. Under addition, right, so it's all about whatever notation that we're using. We're not necessarily using the traditional multiplication. We're not necessarily using the traditional addition, but when we use those notations, then we use these additional associated notations. So under addition, we denote the inverse of a as negative a. Okay, the normal. 3 plus negative 3 is 0. Okay, the normal. So that brings us into the idea of exponents and coefficients, or we start to be thinking in that way. So under multiplication, we can use our usual exponential notation. So if I say a times a times a times a, for example, I can write this as a to the 4th. And this works out perfectly fine, right? Even when we talk about inverse notations. So if I wanted to talk about a to the 4th times a to the negative 2nd power, if I were to expand this out, right, it'd be a times a times a times a times a inverse times a inverse. And of course, these two would cancel out, and then these two would cancel out. So we're just left with a times a, which is a squared. So 4 minus 2 gives us 2. So we still have the same laws of exponents that we see under our usual notations for multiplication. Similarly, under addition, so again, addition notation, right? These things may differ from our conventional multiplication or division. But if I wanted a plus a plus a plus a, using the same number of repetitions here, all right, this is 4a. Cool. And under the usual, all right, if I wanted to talk about let's see here, let's call it 4a plus a negative 2a. Yes, that would be a plus a plus a plus a, there we go, minus a, or rather plus a negative, right? That's really what we want. And then these would cancel and these would cancel as inverses of one another, leaving us with 2a. So again, right, we have the ability 4 minus 2 is 2. So we can combine like terms in the same way that we have previously. We should be really careful about this though. Well, I suppose we don't really end up with a lot of mixed notations, right? I'm not going to end up with 3ab because 3ab means I have ab plus AB plus AB. But this would imply that I have multiplication. And of course, the fact that addition is present would imply that I have both then multiplication and addition. And we're not combining multiple operations right now. We have just one operation, right? A group is defined as a set with a binary relation, binary operation rather, one binary operation. So be aware of that. We're not using multiple operations right now. So we have this idea of exponents and coefficients here. I accidentally wrote it above. That's fine. It looks good. Yeah, excellent. So that's a bit on notations. So that's normal. And maybe it's worth throwing a comment out here. The order of a group is the number of elements in the group. This relates to our previous section. So in section 4, we talked about the distinct groups which have 1, 2, or 3 elements. Now, the group containing one element, that's really not even considered. If you look at the book, I don't even think it mentions it. But the group with 2 elements is a group of order 2. The group with 3 elements is a group of order 3. And later on in this particular section, we're actually going to look at the groups of order 4 because we start to get distinctions, right? We have 2 different groups of order 4, and we're going to kind of make the distinction between those 2 groups by characterizing their subgroups. So that's kind of fun and interesting. Anyway, let's get into subgroups in our next video. So I see you guys back here in the office in just a moment.